Hey, Neuroside. Hello. Good afternoon. Okay. Mm. Okay, I think I'm gonna go make myself some tea and then I'm gonna start. Hey, Carrot Tom. Hello, everybody. Bork AFK. 10 minutes stream starting. Making tea. That sounds about good. Sounds about right. So, as a preview for people who are already here, what are we doing today? Well, I'm continuing the work with on D2, and since the last stream, I made a ton of progress. I changed a bunch of things that were really suspicious in the way I was like doing things before. And what else? Well, uh, yeah, we I got calls almost to work, so let's continue from there, and then maybe we can try and make them more robust because the last time like there were like a few things where I think that if you try to do a call and then you left the server and then you would join again, the server would be borked. So it's finally time to like streamline all these things. So I'll be right back. Okay, it seems that I have some tea still from this morning, so I'm gonna finish that one first. Doo-doo-doo. Hope everybody's doing fine. I saw this thing on Hacker News. Let's take a look. Taxing growth. Oh no, don't tax growth, please. Evil government taxing our startups hockey sticks. Gemini Pro 3 hallucinates the Hacker News front page 10 years from now. 100% Rust kernel is now upstream in Linux 7.4. Huh. Is it time to rewrite sudo in Zig? I think somebody made this. I think I saw it somewhere. Microsoft Office 365 price increase to $40 per user per month. Jesus. And then complaining about nuts again. This is a little bit too focused on the page. What was on that page that day? I don't know. Go to Zig project. No, when I mentioned that somebody made this, I mean somebody made that page. I don't know where I saw it. Lobsters maybe. Would be so funny that they have this stupid shit. Like they have half of the stupid shit on Hacker News and the other half on Lobsters. That would be funny. But no, I think I saw it. Is it in the comments maybe? Mm, yeah. Public verified safe AI level 4. There is something. Oh, I'll explain what I was about to say in a moment. Zigzag Zoomer. Look, I know we just finished the Raspberry Write back in 32. You back in 32. Like, wait, who talks about this? Who talks this way about stuff that happened 2 years before? Oh man, you don't believe back in 23? Oh man, things were so much different. What? But let's be honest. Hold on. Rust is basically the new C++. It's bloated. Compile times are taking upwards of 4 seconds on my neural implant. That's a maskism. These fucking AIs are these fucking AIs are they are so auto celebrative, and there's a worldview in a sense that permeates through the hallucinations, and that's not a worldview that I like. And that worldview is not the organic result of, it's just the training data. No hidden control flow, unlike the mess the AI bots generated in Outer S last month. Huh? We need to take control back from the machines. Allocators are freedom. I've already prompted GPT-11 Turbo to generate a proof of concept. Who's with me? 42 thumbs down. Wait, is this the funny number? Are we getting funny numbered? I think we're getting funny numbered by this. Millennial Bob. Please, I beg you. I'm tired. They showed the preview you looking at something pale yellow and I thought you have Acme editor. No, sorry. It's just Hacker News, I guess. Yep. Thank you. We spent 8 years writing it from C to Rust. Huh. The safety wars of the late 20s. I'm sorry, I don't know why, but reading this stuff, I'm having like this very strong reaction of this thing is this whole thing is like this is like speaking to you the same way that Elon Musk is speaking to you. It's like I don't know. It's so fucking suspicious. I just find everything not just bad jokes, but like suspicious bad jokes. I don't know, man. Why are we still building native binaries? Question mark. WebAssembly maximalist. Oh man, these you have to appreciate though the subtlety of these jokes. It's it's the same. It's the same sophistication that also modern day communicators tend to have, where even the most subtle stuff is so fucking on the nose. Should just be a WASM module running in the kernel's V8 instance that we can write it in TypeScript. But that's supposed to be the WebAssembly maximalist. The WebAssembly maximalist is not telling you to rewrite stuff in TypeScript. What the fuck did this? What? The WebAssembly maximalist wants you to use Rust or Zig or whatever so that they can get a WASM module. You don't get WASM modules from TypeScript. 800. I would add my thumbs down here. Yes. Okay. Yeah. So here's what I'm looking at. Basically, this was not on Lobsters. It was on Hacker News. Gemini Pro 3 hallucinates the Hacker News front page 10 years from now, and so there's a bunch of this is the AI came up with this front page, hypothetical front page. So 100% Rust kernel, telemetry, Starship, blah blah blah. Why I still write raw code instead of prompting the compiler. And then there's one called "Is it time to rewrite sudo in Zig?" And then after people saw these, they asked the guy who made this to also make basically do the same, but like for individual things. And this is one of the individual things that it also got generated. I will say that I don't know how intense this was, like how much effort the author had to put in. But if the AI was able to also all at once produce the GitHub UI, because I believe the story of this thing is that the AI also generated the Hacker News front page, like the GUI part. And so here I would assume the AI also did the same, mimicking GitHub. So, but yeah, I don't know, it's stupid. Look, if you've never done it, in my opinion, by far the best thing to look at to brace for impact, to know what's ahead of you and kind of get used to it, is to watch Ghost in the Shell standalone complex. Ghost in the Shell standalone complex. This, in my opinion, is a Japanese guy who, I don't know, many years ago, pretty much already knew how life would change once things. Well, you know how there used to be a time where you could trust images, pictures, and then there was a time where you couldn't trust them anymore because they could be edited digitally. And nowadays you have people freaking out about the idea of, oh my god, you can't trust video anymore because it could be AI generated, and so now nothing makes sense anymore. Everything is impossible to believe, and it's like, no, we just need to change your mindset and account for the new possibilities. So just like we survived fake pictures, we'll survive fake video. And I don't know, like fake text. I mean, fake text is probably the oldest thing on the planet. So I think this is a cool story that, in my opinion, makes a lot of sense. I highly recommend Standalone Complex. I don't think that all the newer Ghost in the Shells are particularly good. Is Standalone Complex a prequel? No, I don't think so. It's another one, the prequel. I forget the name. Standalone Complex is just, I think it's Arise, the prequel. Standalone Complex is, it's just a one particular story that the group of people that are protagonists of this story have to deal with. So I don't know, I liked it, and it does have to do with the AI to some degree. So what are we doing here? Let's see. Oh, also, well, while we're here and we're ranting, let's keep ranting a little bit more. There's even more discussions about Zig asserts. People just cannot wrap their head around asserts. I don't understand why. And the thing that I find the most confusing about this story is that people are flabbergasted at asserts in Zig, which are just normal function calls. And then on Zigit, there's constant discussions about, do we need a assert built-in? And it's like, why? Why do you want that? Like, you already find confusing the most simplest and straightforward behavior possible, a function call, and you want a built-in. Why? I don't know. It's we need fuzzing. I think that once we have native fuzzing and people start using assertions for fuzzing, then everything will start clicking better for them, hopefully. Medium.com/generative AI. Oh man, that's my shit. Let's go. So is this an account or is this a category? Like, how does it work? All the latest news and updates on generative AI space. Oh, so it's I don't get it. Is this the slop section or is this the section about slop? Am I reading slop or am I reading about slop? Okay, it's about slop. So if this is about slop, why is there an article about Zig? Guys, I think you're getting memed by this stuff. I think you're getting memed, and this section is slop about slop. And in the mix of this slop about slop, a piece of slop about Zig sneaked in. That's my suspicion. Let's read. I haven't seen this. When code walks before it runs, who's auditing the steps? That's already slop. In which compile time execution creates a blind spot in supply chain security, and a developer realizes we've been trusting the compiler a bit too much. Brains, servers. Who is it that was saying that it is not slop? Not sure if article is slop though. I would say there are very, very small chances that this is not slop. But frankly, here's where things become interesting in modern times. You know, you could argue that sometimes it's rude to assume that somebody's work is slop. Like, you know, you made something and then people in chat say, oh, that's slop. That seems rude, right? Like you, if you made this, you would consider that behavior rude. But look, would it really be less rude for me to conclude that somebody willingly, knowingly wrote this stuff instead of making an AI hallucinating it? Like, would it really be less rude of me to assume that somebody wrote this sentence knowingly, deliberately? If I have to be honest, and I end up writing to somebody that they wrote slop, I can promise you I am trying to be less offensive than what I would be by writing a reply under the assumption that this has been written by them deliberately. So this is like, who writes this shit? Like, who writes this? Come on. I hope nobody does that. So in the interest of politeness, I will assume that this is slop. Just so that I don't have to be rude. Oh, okay, let's keep the fucking quote. I ignored Zig for 2 years. Ignore Zig. Bold. Not out of any particular animosity. EM dash. God, uppercase G, knows, bold, there are enough programming languages to be actively hostile toward without adding more to the list. Are there? EM dash. But out of sheer exhaustion, another systems language, another attempt to be better C in a landscape already crowded with Rust, borrow checker sermons. Goes pragmatic minimalism. But we're talking about systems languages. And approximately 17 other contenders I can't even remember the names of anymore. The ban hype train rolled through. I watched it pass. Then it came back due to Claude taking over it. Roller coaster. Are we... what? What is this slop, man? The Zig is the future posts accumulated in my feed. I scrolled past them. The same pattern over and over. New tool promises revolution. Developers get excited. I get older and more tired. No, you don't. No, you don't. You're just a run through. you're just one prompt on ChatGPT, man. Relax. Just another hype cycle. I was too exhausted to care. Got other things to keep myself busy. Like, for instance, then came supply chain attacks. Let's see what the AI thinks is a supply chain attack. Which, by the way, this is so funny because this whole concept around supply chain attacks is in good part hallucination by humans. And then you have like It's not like the AI cannot have a good opinion on this shit because humans don't have a good opinion on this shit. Almost everybody that writes about this topic, like almost everybody that types these words is already hallucinating. So it's the purest form of garbage in, garbage out in a sense. Not the first ones, EM Dash. We had those for years, escalating in both frequency and management panic levels, EM Dash. But the recent wave that hit the Node ecosystem, but the recent wave hit the Node ecosystem particularly hard. The kind that makes your Teams channels light up at 3 a.m. The AI uses Teams. My man. Man. Okay, they need the more relanium. I don't even know what that is. The kind where you're scrambling to audit dependencies you didn't even know you had, checking if some package 17 layers deep in your node modules decided to phone home to an interesting IP address. I've been on the receiving end of those incidents. You know what's funny? That's probably true. I would not be surprised if some companies have an AI wired to their like emergency tickets, whatever those things are called, to their like incident tickets. Enough times that I've developed what you might call an expertise through repeated beating. Not the kind where you become a security expert. I'm not a pen tester. I don't write exploits for fun. I just work as what you might generously call the court poet for programmable things in a fairly large institutional manufacturing company. My cybersecurity credentials are simple. I've been hit in the face by enough attacks that, through sheer repetition, quantity eventually transitions into something resembling quality. Yo, what's happening here? What is this? What is this URL? What is this URL? Wait, what is there a bajillion dashes in there? It's okay, let's see. Quotes another blog post. A confession, I don't actually live here. But why are you making something this long? I don't get it. Process environment and generate code assigned to message. This runs during compilation, not as a macro, as actual code, with full language capabilities. Whatever this function does, it happens before the binary exists. Yes. Yes, you already said that like 3 times. Wait, this is also funny. This isn't Rust's const fn, which lets you run a carefully constrained subset of the language in compile time context. Functions marked as safe enough to run when the compiler needs them. What? This isn't C macros, which operate on tokens like a particularly aggressive set script that's achieved sentience and become rather pleased with itself. This is the entire language available during compilation with the same capabilities as runtime code, but that's not true. Comp time is limited by design. You can't do anything, even like this thing environment. I guess it depends on what you mean by environment, but like you can't access, you can't do syscalls at comp time. So, oh man, wait, what the fuck is happening here? You know what I think is the worst part of this? This was not like one shot prompted by somebody. I think that somebody put some effort into prompting this whole thing into like multiple steps. Why this pattern will spread whether we like it or not? What, like, why? 2 decades? of code wrestling, humbled daily by imposter syndrome. AWS Wanderer. What the fuck is an AWS Wanderer? It's like being a little traveler. Like, what? Devoted gopher, stoic, Taoist, cynical Epicurean. 4 responses. Time to read the responses. This is a really interesting one and potentially the only practically useful scenario. It sparks some interesting thoughts I should write down and may have to explore at some point. 21 claps. Oh man, I really love it. First, I'm really flattered to see that I could help someone to write such and thoughtful analysis. Second, I'm fully admit that while having fun with Zig, it's in the spirit of joy of programming. Not even once I thought about security implications of having fun being able to just code. And your article is really raising concerns, especially with those recent NPM attacks. You bring valid points. While both Java and .NET historically put a lot of explicit focus on security, native languages never circle those concerned the communities. But last but not least, I enjoyed your article. But my favorite part is actually blah, blah, blah. I feel you. I really feel you. Is this somebody that was quoted? Oh, this is the same account. By the way, you might want to share your article with Zig's community. There are Comptine and build system has limitations, including for security reasons, but I do not think they will ignore potential implications if they just do not put as much attention to this threat. They might even reach out to their clients like Tiger Beetle and Bun. Those might want to review their CDCI pipelines, especially Bun. So was that account from the other blog post that was quoted in here? Which, well, man, how much will I have to scroll to find that shit? Oh no. Oh god damn it. Now it's way more up, right? It was near the beginning. There you go. Olenin Slava. That's the same person, isn't it? Yeah, Olenin Slava. Let's go. Why I'm falling in love with Zig? The picture already. I feel like this picture is already. You know what? I would call this picture like Chekhov's picture. From Zig critic to evangelist, the story of how a conservative engineering lead slowly turned into an addicted vibe coder, kinda. What the fuck is going on? Walking home at night, past a group of youths. One of them tells me I dropped my gay card. I look down for it and realize I've been the victim of a practical joke. I'm unmoved. I tell the youth that his provocations are futile because I'm a stoic. He bursts out laughing and says it's pronounced stoic. Stoic? Not stoic. I break down and cry in the street. Not very stoic of the guy, but we do what we can, I guess. Why are these people like this? Why are they like this? Why are they doing this Why are they doing this stuff to themselves? Like, look, create an account. Look, bro, you wanna read? Look, this is good shit. You wouldn't expect us to give this stuff out for free, right? So, man. There we go. Here's the other guy. It's a shame I cannot give more than 50 claps here. Oh wait, you can? So these are not given by like oh, you pass them around like currency then. So like the 20 claps were not like 20 different people clapping. They were coming from one guy. Like how, what the fuck? I have to say I literally love your approach. In this, well, okay. I'll drop it. Let's continue. Initially, I have expected some sort of clickbait article. Like, world was dark, but then I found novelty language and I see the light. But nope, you simply dissected ordinary yapping and went down to the very low level of personal DX and productivity. Now you've made me want to try Zig. Medium is mostly about having fun writing and hopefully getting paid to do it. Hobby writers, it's not about the actual content. But this is not hobby writing. Like, this is really not hobby writing. This is, well, this I don't know because I can't even read it. But if we look at the previous blog post, this is not hobby writing. This is like, I wouldn't even know what to call it. This is pollution. This is like going in public and farting loudly. Like, you can do it, but also just keep your fucking farts for yourself. Oh man. Okay, what an adventure. Jesus. Oh, you know what I forgot to do the other day that I wanted to do? So while we're here, let's do one last bit of yapping and then I'm gonna start working. By the way, I got calls to work, so I can even demo this stuff, although it's not a particularly cool demo. Yeah, so D2 is getting back into shape. This is what I wanted to talk about. There was something about async. Hello X2. So there is I think there was an LWN blog post, right, on async. Zig's new plan for asynchronous programs, which I already read, and it was generally fine as an article, some imprecisions, but then the author then fixed after reading a comment from Andrew. And I saw some comments. So, and there's probably more comments now. I am amazed at how just nobody understands any of this stuff at the level that they should, which is sad, considering how much we use async and await every day. Like there's a bajillion web services that do async and await all over the place, and the people that do it don't understand anything about it. It's insane. Let's see. So instead of function marked async or not, you schlep an additional IO parameter all around your call chain whenever something might or might not need to do anything async. Doesn't seem much different from tagging everything you want to asyncize with async and await. Also, I'm interested in how Zig plans to manage an event loop this way. What do you mean plans? It works. It's there already. I mean, you need to save and restore the call stack somehow. Oh God. And stacks may not exactly be small in a production setup. What? Bro, stacks are already saved in memory. That's where they already are. Like, where are you putting your I what? Where's the stack going to go, man? What? I, I, I think this person is thinking that stacks exist inside like CPU cache. You know, it's like, dude, put the stack in the bag and nobody gets hurt. Do it now. I want small stacks, unmarked, not the ones from the bottom of the memory address space. I think they're talking about the stack pointer. Yes, you have to say the stack pointer, but a stack pointer doesn't care about stack size. So lots of confusion, but could be worse. 15 responses. Oh, wait. So these all down below are 15 responses here. Jesus. Okay. It's a bit different because the syntax of the function involved doesn't change. You can store an IO in a data structure or global variable if you want to, but I agree it's separately onerous to have another piece of context support around everywhere. As for managing the event loop, I believe the plan is for there to be built-in functions that can start executing a function in a user-provided stack. People are making such a mess of these things because they like the reality. I guess what they're thinking about is stackless coroutines, because this is another thing that everybody does. Async has to mean stackless coroutines. What else could it mean, right? And that's another way of completing things that doesn't help anybody. As for managing the event loop, blah, blah, blah. Okay, let's see. Piece of context support around everywhere, similar to Go, which also has 1.5 colors function, taking a context as the first argument and most likely performing IO. You know what's the funniest thing? That we don't even have that, because you can launch any function as a coroutine, and that function doesn't even have to be it doesn't even have to accept any special parameter, not even IO. You can launch as an async function, a function that doesn't take an IO parameter, and you will still be able to cancel it if that function is doing IO of any kind. So, I don't know. I don't know what people are smoking. Similarly, in async languages, Rust, a function marked async might end up performing no IO at all, no await points. A function marked sync might spawn its own runtime or grab the global one and start spawning futures, =, called async functions on it. Lots of gray areas. Okay, so I love discussions about how everything is function coloring, but let's see if there's anything else. There's an analogy in there somewhere, but no. Asynchronous code and threaded code have some similarities, but are different. Async code is about trying to do cooperative execution in a single thread, and often with little to no runtime support. Threaded code with language support typically means a runtime system with a threaded scheduler and some compiler support to implement proper thread preemption. Compiler support to implement proper thread preemption. This is another soup of concepts that makes no sense. So this person is saying that you can have cooperative scheduling and preemptive scheduling, sure. And OS threads, generally speaking, are preemptive coroutines with preemptive scheduling. But again, calling this async code is very imprecise. But let's say that this person means like stackless coroutines. I'm not sure what the compiler is doing exactly to support threaded code, but fine, let's assume it's doing that. In Haskell in particular, which is what I'm familiar with, the compiler doesn't need to make everything async. It compiles to very traditional looking low-level sequential code. The only magic is the compiler inserts yield points where it anyway has to do stack or heap checks. And yes, there is a thread scheduler in the runtime system, and thread synchronization primitives interact with the scheduler too, of course. Turning everything async is rather different compiler transformation. So this person is talking about green threads versus stackless coroutines. I think maybe. It's hard to know. I don't even know if they know. I agree that Haskell code compiles down to code that looks more like threads than like Rust async. But you can describe this stuff more precisely. You can say which model is Haskell using. It's probably green threads, I guess, but just use the name. Just say what it is. It's green threads. And Rust async is stackless coroutines. And yeah, those things will look different. But that's at least partly because of Haskell's design as a language has pervasive support for suspending computations as part of being a non-strict language. What is this non sequitur? This. Wait, what? Okay, maybe I'm misunderstanding then. Okay, maybe I misunderstood. I must have misunderstood. Either I have misunderstood or this sentence makes no sense. So what the sentence is saying is that Rust is particularly good at structuring computation as something that can be paused and resumed. Then that means that Haskell is also doing stackless coroutines then. And this person is saying that it's better than Rust at doing stackless coroutines. That looks more like threads. The unit is just the thunk, not the asynchronous function. Right. For people who don't remember, a thunk is a function. Basically, it's a function to which I guess you give it a function and arguments, and then you have this function that when you call it, it calls the function plus arguments that you gave to it. And anyway, something like that. Okay, these comments, I would say not the greatest. Haskell compiles directly to thunks. How you execute them is not determined by the compiler. Okay. So it's kind of like what Rock wants to do, right? I think there were comments also on Lobsters about that blog post and also Hacker News. $262 comments. Okay, let's ignore Andrew's comment. We don't care about that one. No, he's actually pointing out one imprecision in the blog post. I think this design is very reasonable. However, I find Zig's explanation of it pretty confusing. They've taken pains to emphasize that it solves the function coloring problem, which it doesn't. It pushes I/O into an effect type. Bro, the fuck is an effect type? Which essentially behaves as a token that colors need to retain. This is a form of coloring, albeit one that is much more ergonomic. To my understanding, this is pretty similar to how Go solves asynchronicity, except that in Go's case, the token is managed by the runtime. This is so much nonsense. If calling the same function with a different argument would be considered function coloring, then every function in a program is colored and the word loses its meaning. Why are they so hung up in function coloring? Because they think they understand the analogy. Like they see the analogy, they pattern match it, like they pattern match it to whatever random thing in their mind vaguely resembles function coloring. And so they say, bam, that must be it. Now, boom, now I understand async. And it's unfortunate because the fact that people have to feel like that they have to rely so much on an analogy, if you think about it, it speaks so sadly about the state of our industry, because it means that we don't have technical terms that we know how to define, use, and explain to others in a way that we can meaningfully convey what this stuff is. And it's really sad, like really, really sad. And then you end up with situations like this. Let me see if I'm still logged in. And then you end up with stuff like that. Oh my gosh, are you trying to say concurrency isn't parallelism? Using asynchrony for concurrency and concurrency for parallelism? Seriously? Like, and everybody has like their different definition of these terms. It's so funny. Also, you know what? You cannot say that concurrency is parallelism because Rod Pike made that one talk that everybody likes to quote. And so, no, concurrency is not parallelism. There's that talk, so you can't say that those things are the same. Which I'm not saying, by the way, but that's another piece of pop culture that people tend to usually know by heart. Also, by the way, I don't know if it's a Y or an I. Nobody mentioned that talk. Insane. Nobody on Hacker News mentioned that talk. Actually, are we equally lucky on lobsters? Oh, we might be lucky also on lobsters. Nobody has quoted that there either, it seems. Woo. Well, in any case, so people are duking it out in here. Let's continue to the rest of the comments. Let's see what they say. This design seems very similar to async in Scala, except that in Scala, the execution context is an implicit parameter rather than an explicit parameter. I did not find this API to be significantly better for many use cases than writing threads and communicating over a concurrent queue. There were significant downsides as well because the program behavior was highly dependent on the execution context. It led to spooking action at a distance, problems where unrelated tasks could interfere with each other, and management of the execution context was a pain. My sense, though, is that the Zig team has little experience with Scala. Yeah, you're welcome. And thus do not realize to the extent to which this is not a novel approach, nor is it a panacea. It's incredible that the novel part is not having these parameters. Everybody hyper focuses on the fucking parameter. IO is defined to be a parameter right now, but it didn't have to be. Like, we could have very well defined a global IO implementation that you override in your main function that you use globally in your program. So you wouldn't have to pass the argument around and everything would still be the same. Like, not only you can do that stuff manually on your own in some scopes, but IO could have very well be a global argument that there's a singleton of in the standard library. Like you would do std.io, for example, to do stuff on it, where std.io is not the type. std.io would be the global instance. And so lowercase IO, basically. And everything would work exactly the same. Same with allocators. Yeah, of course. Of course, same with allocators. Yes. So, in this case, the point is not just this is the type of the interface. The idea would be to have something like this. Well, something. I'll show you something like what. Guess what? This is my chat application, and no, never mind. Here I don't have a global IO. I do have a global IO somewhere though. This IO will become global in any case soon. Let's see if I have it in client, a global IO. No, I don't for now. But this is gonna become a global. I have a global allocator here that I use throughout the core logic of my program. And I'm also gonna have a global IO, so you can do it a global IO instance, not just the type. So you can do it. That's not the point. The point is distinguishing between async and concurrent. That is the novel part, is the ability to not split the ecosystem. That is the novel part. Plus maybe some other stuff, but that's the main stuff. Let's see. The problem with using OS threads, you run into scaling problems due to little slow. On the JVM, we can use virtual threads, so green threads, in normal lingo, which don't run into that limitation, but the JVM can implement user mode threads more efficiently than low-level languages can for several reasons. The JIT can see through all virtual calls. The JVM has helpful restrictions on pointers into the stack, and good GCs make memory management very cheap in exchange for higher RAM footprint. So if you want scalability, lower-level languages need other solutions. This is interesting. So here Pierron is saying that JVM has some advantages over low-level languages, some of which we do plan to tackle. For example, this pertains to restricted function pointers, the proposal. This part we don't have, but in theory, if we can learn stack at compile time maximum stack size, we should be able to solve these two problems. We will basically have our own version of these advantages. So we'll see. Anyway, one thing the old Zig async await system theoretically allowed me to do, which I'm not certain how to accomplish with this new IO system without manually implementing it myself, is to suspend resume. Dude, good luck implementing suspend and resume manually yourself the way you're thinking, because all async await in Zig was cyclist coroutines, and suspend and resume was a compiler transform. So I don't think you can implement it yourself. For green threads, you can, but we have it, so like it's already available. Why do we need restrictions on pointers to the stack? What I think Pierron was hinting at, I don't know that for certain, but what I think he's referring to is the fact that in his case, they in the JVM, they're able, if they want, to resize a stack and move it in memory. And the reason why they can do that is because they know when there are pointers to memory in that stack somewhere else, and they can fix those pointers. This is a thing that stuff with a runtime, languages with a runtime can do. Go, for example, does the same. In our case, we don't have this. We don't know when a pointer is into the stack memory. We don't even know which pieces of data are pointers, because well, more in general, there's no runtime. Zig doesn't have a runtime, so they would be able to do this stuff. So in our case, basically our quote unquote equivalent of this would be the fact that if restricted function pointers is implemented, we will be able to know the correct size of a stack at compile time, and thanks to that, we will be able to have stacks that don't need to be resized, stacks that are exactly the right size to make space for the longest, deepest cold chain that you have, and so you never do stack overflow. But at the same time, they are not oversized. Like you could today, for example, say, you know what, I'm going to create every coroutine with 200 megabytes worth of stack, and chances are that that's going to be good enough. But also, you can't have too many of those things flying around if each one of them is 200 megabytes big. So that's the idea. So this is about doing an OS, so I'm going to skip this. I'm excited to see how this turns out. I work with Go every day, and I think Yo corrects a lot of mistakes. One thing I'm curious about is whether there is any plan for channels in Zig. Yep. We have io.q. It's weird that there's a select keyword in a language, but you can't use it on sockets. That is actually a feature, not a bug. Wrapping every IO operation into a channel operation is fairly expensive. Yep. Yep. You can get an idea of how fast it would work now by just doing it, using a Go routine to feed a series of IO operations to some other Go routine. Well, have you tried Odin? It's a great language that's also better C, but takes more Go inspiration than Zig. Second vote for Odin, but with a small caveat. Odin doesn't and won't ever, according to its creator, implement specific concurrency strategies. No async coroutines channels fibers. The creator sees concurrency strategy as well as memory management as something that's higher level than what he wants the language to be. At least Go didn't have the dark path of having async/await keywords. Oh man. Those keywords, despicable. Absolutely despicable. In C#, that is a real nightmare and necessary to use async over async anti-patterns unless willing to rewrite everything. Yeah, but man, that is because Go is doing green threads and C# is doing stackless coroutines. It's not the keywords. It's the runtime model. I'm glad Zig took this colorless approach. and then here comes the counter. Where do you think the IO parameter comes from? The IO parameter is born of the function coloring fountain. If you change some function to do something async, now suddenly you require an IO instance. I don't see the difference between having to modify the call tree to be async versus modifying the call tree to pass in an IO token. The fuck is an IO token, man? Also, this whole idea that it's a token. It's like you ask the AI for, like, you pay the AI system to do async stuff, and so you pay your IO token to it. Like, what does a token even do? Oh man. Synchronous IO also uses the IO instance now. The coloring is no longer is it async, but does it perform IO? This allows library authors to write their code in a manner that's agnostic to the IO runtime. Let's go. The user chooses synchronous, threaded, evented. I wouldn't put synchronous in the mix with these things, but fine. With stackful coroutines, evented with stackless coroutines. Let's go. Did this guy reply then? Rust also allows writing async code that is agnostic to the async runtime used. Subsuming async under IO doesn't change much, in my opinion. Bro! Look, I guess you can't save them all, but god damn it. An effect token is a thing that exists with which you can do side effects. Is this some like functional brain terminology? I don't know. It seems so weird to me. Except that now your library code lost context on how it runs. If you meant it to be sync and the color gives you a n multi-threaded IO, your code can fail in unexpected ways. How so, aside from regular old thread safety issues, that is? That is exactly the problem, thread safety. The function being supplied with stdio needs to understand what implementation is being used to take precautions with thread safety. In case a stdio thread is used. you can take a piece of code and run it in a multi-threaded application and schedule calls to that fucking function on multiple threads at the same time. And if your function is not thread safe, then it's a problem. And it was even before std.io. Like, you were allowed to schedule stuff on threads even before std.io. So yeah. What if this function was designed with synchrony in mind? It hurts. This usage of synchrony kind of hurts. Actually, you would even argue that if the function was designed with synchrony in mind, then because of that, you would make sure to take into account multi-threading. It's when you're not thinking about synchronization with the rest of the program at all that, in a sense, synchronization is the problem. If your function doesn't work in a multi-threaded ecosystem runtime, it's because it's trying to synchronize on data that is not properly protecting with synchronization primitives. Anyway. The function being called has to take into account thread safety anyway, even if it doesn't do I/O. Yep. This is an entirely orthogonal problem, so I can't really take it seriously as a criticism of Zig's approach. Libraries in general need to be designed to be thread safe or document otherwise, regardless of the I/O. Yep. Because a calling program could easily spin up a few threads and call it multiple times. Yep. You know, in a state, they will take performance penalty if multi-threaded mode, the same as any other library written before this point. One of the harms Go has done is to make people think its concurrency model is at all special. Go routines are green threads, and a channel is just a thread-safe queue. No, a channel is a little bit more. A channel is a thread-safe queue that can close. By the way, for people who are interested, io.q right now in Zig doesn't close, but we're going to add the ability to close soon. I think mlag wrote it in a branch. He needs to upstream that. So our queue also will close, and I'm personally lobbying for renaming it from queue to channel, because in my mind, a queue can be thread safe if you want to make it, and it is a thread safe queue. But if your queue also has the ability to close, then it's a channel. That's personally how I look at it. So I'm also lobbying for renaming it. A channel is not just a thread safe queue. Holy shit. What does the ability to close mean? It means that you can, there's like a Boolean in it that says whether the thing is open or not. And you can flip it closed. And when you do, you automatically unblock all producers. So if there were, for example, let's say there's a queue that can hold 10 elements and it's full, and another coroutine is trying to put stuff in it. So it's blocking, waiting for some free space to be made for it to put something in the queue. When you close the queue, you will unblock the blocked producer, and the consumer then can keep consuming. And when it sees that the consumer will keep draining the queue, so even if the queue is closed, if there are still elements in it, consumers will receive elements in the queue. But then when you reach the end, so when the queue has been drained completely, then you will receive error.close also on the consumer end. And you know as a consumer that once you receive error.closed, then the channel cannot be opened again. Like it's you're done. It's time for you to, I don't know, return, or I don't know, move to another channel. I guess it depends on what you're doing. But yeah, these are the semantics of closing. I think his point is that with an IO.event, you do not need to have any synchronization, and it would not work with a threaded implementation. That is not exactly true. So if you're saying you don't need mutexes for accessing like a piece of data, maybe. But here's the thing: IOTA evented doesn't mean single threaded. In some ecosystems, it means single threaded. For example, in JavaScript, you are doing evented but single threaded, and so you don't need mutexes in JavaScript. Sure, in Node more specifically, sure. But for example, in Go, you still need mutexes even though you're doing Go routines because it's multi-threaded. So you can have multi-threaded evented systems, and those will need mutexes. Let's see what Jerov is saying. A channel is not just a thread safe queue. It's a thread safe queue that can be used in a select call. God damn it, dude, you were so close. No, it's not true. It doesn't have to be something that can be used in a select call. It depends on how you define select. That is not the defining characteristic, man. God fucking damn it. It's a channel that can be closed. And it's the closing part that is the key. Because this was actually something that was pointed out to me recently on Zulip, because I wasn't thinking about this use case. In my application, when something goes wrong and it's time to, for example, close a connection, I don't care. I kill all the coroutines that were managing that connection. And if there was some, for example, message in the inbox/outbox that needed to be processed, I drop it and I don't care. Or rather, I don't know if you know what? If those need to be freed, then that would be a problem. But so far, given what I was doing, I didn't care. So I would just leave those things in a channel that would end up being freed. But if you want to have proper shutdown where you guarantee that you drain the channel, you can't just cancel the coroutine. That's what I was suggesting wrongly in the Zulip discussion. You cannot just cancel the coroutine. You have to first guarantee that the coroutine has processed all its pending messages. And closing the channel is the best way of doing it. It's the most natural. There are probably alternative approaches that you can use, but that is the best one. One, for example, could be that you put a special element in the queue. So you have an element that says, a sentinel element that says, look, I am the first sentinel. If you see me, then it means that we're done processing and it's time for you to return. And that works. The problem, though, is that if you have multiple consumers, then this approach becomes problematic, because then you need to generate one of those tokens per consumer, because each one of the consumers needs to see the sentinel element and thus return. So, and then if you have an unknown, and then that forces you to have a known number of consumers, because if you have a unknown number, like if you don't keep track of how many consumers you are, then you don't even know how to do that correctly. Like, it becomes super weird. So that's why closing is just useful to have. Let's see, select is the distinguishing feature, not the queuing. Ah, man, so close. So close. So close, man. And it's quite freeing not to care about mutexes. You do not get the luxury in Zig. Sure, you can write crappy code that doesn't support multi-threading, but in general, if you want to make a high-quality library, your code needs to be thread safe. The reality, by the way, is that very oftentimes you don't need to have explicit mutexes. Like, there's a lot of stuff that is perfectly correct in a multi-threaded context and has zero mutexes in it, because everything, let's say that you make a parser. When you make a parser, you make multiple instances of that parser. And so the idea is that every thread will have its own parser or parsers. So you don't have one parser used by multiple threads. And if you want to do something weird like this, then it's going to be on the user to protect that thing with a mutex. But the point is that in Zig, if you're doing a good job, you want to be aware of multi-threading when making a library. When you're not making a library and you're making your own application, you decide what to do. It doesn't matter. It's entirely on you. If you want multi-threading, single-threaded, or whatnot. And more in general, it is also true that if you make a single-threaded application, then you can. Here's the thing: if you make a single-threaded application and your code, maybe some library code that you're using, has mutexes in it, here's the funny thing: when you build in single-threaded mode, mutexes become no ops. Like at runtime, any call into a mutex becomes nothing. Any struct that stores a mutex doesn't waste any bit because mutexes become of size 0. So there really is no downside to just writing code that is more reusable. Yeah, you don't really care. Yeah, and in your code, in your application code, you can do whatever you want. But the point is that you will still want to use libraries that are potentially like you can still use good quality libraries that have proper handling of thread safety. And then if you use the single threaded flag, you don't even have to pay any price for it. So you can have your cake and eat it too. Okay, so there's a lot of discussion about Go. Jesus Christ. I find this example quite interesting. Let's see, save file, save file. In Rust or Python, if you make a coroutine by calling an async function, for example, then the coroutine will not generally be guaranteed to make progress unless someone is waiting for it. I don't think this is true at all. Like, I think this is true for Rust, but not for Python. Can somebody who does Python confirm this? I feel fairly confident that it's not a waiting that makes the coroutine move forward in Python. I suspect that the Rust propaganda has infected people's brains and made them hallucinate things about other languages. Because you hear a lot about Rust async and how in Rust async you need to poll futures because if you don't poll the future does not make progress. Which is, by the way, and it's such a weird choice. And also interesting that nobody bats an eye to this idea that you're doing polling. Why are you doing polling? Why does it need to do polling? There are more precise ways of driving these things. Why does it have to be polling? Anyway, in contrast, if you stick the coroutine in a task, the task gets scheduled by the runtime and makes progress when the runtime is able to schedule it. Oh, so this person is using a more precise terminology. So I think that when they say coroutine, yeah, I think that, okay, so when this person is saying coroutine, is talking about like, what are they called? Like def star functions? No, that's a generator function. So is async in Python based on those things then? In contrast, if you stick a coroutine in a task, the task gets scheduled by the runtime and makes progress when the runtime is able to schedule it. But creating a task is an explicit operation and can, if the programmer wants, be done in a structured way, often called structured concurrency, where tasks are never created outside of some scope that contains them. From this example, if the example allows the thing that is io.async to progress all by itself, then I guess creating a task that lives until it finishes or canceled by getting what. From this example, if the example allows the thing that is io.async to progress all by itself, then I guess it's creating a task that lives until it finishes or is canceled by getting destroyed. Yes, I guess, given what I assume is the terminology being used here. this is certainly a valid design, but it's not the direction that other languages seem to be choosing. Whew, so much confusion, man. For async IO, you can run it in an executor and drop it if it will still run to completion. Not sure if that counts though. The runtime might be doing the polling. I don't even know. I don't know, man. Okay. I don't know what this stuff is doing. Like I'm trying to remember how async IO worked in Zig back when we had stackless coroutines. You had to progress coroutines, but you would progress coroutines not by awaiting them. You would progress coroutines by the coroutine would start eagerly, and then it would I don't know if waiting on IO, like you basically want to run in a coroutine, reading from, I don't know, connecting somewhere and reading from that connection. So when you first launch the coroutine, then the code, it immediately starts running a little bit until it encounters a suspension point. And then when it encounters a suspension point, that's the old implementation. We don't have stackless coroutines right now, so I don't know how those would work. But it would hit a suspension point, and then based on, well, before hitting the suspension point, it meant that it had that it needed to perform some IO, for example. So the coroutine would end up being subscribed by to, I don't know, KQ or whatever, and so the external system would then notify our process that file descriptor X is now ready to read. And then that would and that notification would also contain the payload, a pointer to the coroutine, to the corresponding coroutine that would need to be woken up. And so we would wake up that coroutine, which would continue executing up until the subsequent suspension point. So I don't know. Let's do some programming. Enough stuff. Okay, let me demo what I have so far. Here's what I have. I have a server which I'm running with the echo. So this is a server that echoes your voice back to you when you send something. Also, for the benefit of the people on YouTube, I'm going to turn on audio from my Mac also on YouTube. So I start the client, and I'm going to enter a voice channel now. And since we have echo on, it should echo back my own voice. So let's see how this goes. Test, test, test. I think you can hear it also maybe echo more than once. It's because I hear it in my headphones, and I don't have like a communication threshold, that kind of stuff. So okay, leave call, and that's a crash. I haven't implemented what should happen when you leave a call, or rather, I had implemented it in the past, and now I need to wire it back in. So that's where we are. At. One good news regards to the past is that I have not restarted the server, and as you can see, this still works. So I don't have to restart the server. It used to be that I needed to restart the server every time I joined. Again, because it wasn't complete and I had some like cleanup code that was missing, which I still have. There's still some cleanup code that is missing, but what's there, it's already good enough to not break this functionality and force me to restart the server every time I want to enter a call. Coroutine main was never awaited. Python coroutines have to be awaited. They're not eager like in JS. That doesn't say much. You have to await coroutines also in Zig. In Zig, it is UB. It's IB. It's a legal behavior to not await a future. So already seems more robust than it was. It probably is to some degree, but in all honesty, I have not changed any of the audio handling code. All the old code still works as it was before, pretty much. And I think that the quirks that we were experiencing by having a real network in the middle and not stuff being just localhost are probably still here. That's my suspicion. But you just work on this stuff a bit at a time. I am really looking forward to opening these to contributions. I don't know. Let's handle closing a call then. Hi, Loris. Is there any plans to address the casting situation? Make single line equations very long. I prefer having shorter ones. Like we used to have the ability to do stuff like this, not exactly with this syntax, but it was removed. The reason is that if you have a cast that hard codes a value, you risk having this. This is why it was removed. You have foo, which is of type I don't know, U64, or let me think about it. Yeah, U64, and then you have here int cast. The old int cast was like this. Int cast to your target, like U64, and then your original value. So we used to have this. You could specify the target type immediately without having to wrap everything in as. The problem is that those things can go out of sync though. For example, you do this, and this is still fine as long as you're targeting a 64-bit system. But then the day that you try to compile for a 32-bit system, this doesn't work anymore. And I think there's more examples of this where it comes to unexpected consequences when upcasting. So like you maybe you had it, what was it, like U32, this was a U32, but then you decide at some point to widen this to U64, but somewhere else you have some math that doesn't get updated, and now these guys can only fit a U32, and the upcast will succeed silently. And like imagine that this code is not immediately here; it's like a little bit removed. So long story short, it will work, but then you might have when you update it to U64, you maybe intended for your update to have a different semantics. So long story short, it is very much on purpose that you inherit the target type from the context of the expression. This is currently not great though. The system is currently very very restrictive, and it will be less restrictive in the future. I don't know precisely how that will look like, and you don't know until it's done. But I think that in general, the target type will permeate more into your mathematical expressions, so that you will have to use this stuff less. So this is definitely something that we'll be looking into in the future. But this idea has been discarded. This is how it used to be, and it has been discarded with an explicit reasoning. If my explanation doesn't convince you, you can find this explanation explained somewhere. The probably release notes, although I don't remember the release notes of which version of Zig. And you can probably also find discussions on GitHub. Could you please explain once again naming convention for allocator function parameters? Yeah. Usually the way I do it, I'm not the only one. A lot of other people do it, and I would recommend it. Let me put it this way. For now, I do not know a better way of naming these arguments, but the recommendation is if you're making a function, by the way, I'm putting a function definition in the body of another function, which is not valid Zig, but just to type something somewhere. When you're defining a function, you accept always an allocator, but you accept it as named GPA if you are accepting an allocator for which you expect to create individual allocations that have like different lifetimes. So for which you will make foo, so you will do GPA dot create foo, const foo, and then you expect also to be able to do gpa dot destroy foo, or if it's multiple elements, alloc free. So this is one style of allocator, and the implementation can vary, but the idea is that this is an allocator that tracks individual allocations, and that's going to be GPA. And then another type of allocator that you can ask for is an arena. You still accept it as an allocator, but the idea is that you're going to allocate stuff in the arena. You're not going to free it because you assume that the arena is unable to track individual allocations. So calling free on something won't be useful unless it's the very last thing. Like you can read the documentation of the arena to learn more about what I'm talking about. But arena doesn't track individual allocations, but it is able to free the last allocation. So as long as you allocate something and free it before allocating something else, that free will happen for real. If instead you allocate, and then free the first element, that's a no, you can't. Or it won't work. It will not do anything. It will not error out, but it will not work. And the arena is meant to be reset at some point, like cyclically. So that means that whoever is calling this function, passing in an arena, will be the one that will take care of freeing everything that you put in here all at once by resetting it. The idea is that arenas tend to be used so exact usage depends on what you're doing and the contract that the caller has with you or that you define with the caller. So programs can do different, it can have their own semantics, but in general, an arena, it's kind of like a scratch pad. You put in the arena temporary stuff that, for example, if you're writing a web server and you're handling a web request where you are doing a get from a database, it's totally fair to allocate the response from the database, all the rows, the data that you're collecting from the database for fulfilling this request into an arena. Because the idea is that you will use this data to produce a response to the client, and then once you return, you can reset the arena all at once. There's no point in having in freeing individual things in the context of a, request response in an HTTP request response cycle. That's the idea. And so I would suggest against doing this. Don't accept an allocator named allocator. Don't accept an alloc called allocator, in my opinion. Accept a GPA if you want a general purpose allocator. Accept an arena if you want something to be used like a scratch pad. And this also allows you to ask for both at once. This means that you can have a function that has both a long-lived allocator for stuff that needs to live longer than a function call and an arena that can be used as a scratch pad. If you have a function that takes a GPA, is it weird to create an arena with it at the top of the function? Not at all. No. It totally makes sense. You can totally do it. Sometimes it is convenient to expect an arena if you are in a context, in a function, like having a function that accepts an arena. If you are in a context where the same arena can be reused multiple times, because if you make the arena at the top of your own function, then you will reset and then destroy it, and then you will have to recreate it. While if you're like under the assumption that you're being called like in a loop, if you hoist it out of the loop, so out of the function call and then out of the for loop, then you can just have you create it once, the arena, you create the arena once, and then in the for loop, you use it and then you reset it. You use it and then you reset it. So that way you kind of save some work. But I guess the point is that you need to know that you're going to be in that situation. Otherwise, creating one for yourself, like creating an arena on top of a GPA, it's absolutely fair game. For sure. Is there any world where you might want that as two distinct interfaces? Maybe. I mean, if you phrase it that way, I can imagine there might be a world where you might want to do this. In general, I would say it's fine in my experience when you're doing stuff. So, there are two distinct behaviors, and the only thing in common is I can allocate with both of them. I use my own Scratch type that lets me create and restore checkpoints like a layered arena that I pass around. Be careful with nesting arenas because the sub arenas are easy to use in a foot gunny way. We investigated at some point the idea of adding to arena the ability to create sub arenas, and our conclusion was that the best thing you can do is to create an arena on top of a page allocator. So instead of creating the arena on top of GPA, maybe this is another thing that it's worth pointing out. It is absolutely fair game to create an arena on top of page allocator. You do not have to create an arena on top of a GPA. You can, and it will be fine, but you also totally can create an arena on top of page allocator, and it will work also fine. And it will work also fine, and it actually performs better than the former case, than if you were to use GPA as the base allocator, in case that you want to create arenas nested in arenas. So I was saying to not have that we explored having the explicit concept of sub arenas in an arena, and we concluded that it's actually not preferable at all to just creating an arena inside of an arena, especially if the outer arena is built on top of page allocator. We did this on stream at some point with Andrew. I don't remember all the reasoning, but I remember that I was actually the one proposing maybe we should have sub arenas, and then we started doing this stuff, and we concluded, you know what, never mind. It's actually better to not have that. And if you want to do some kind of checkpointing of the arena, just nest arenas, and that's like good enough. Okay, so what happens when we leave call? Also, there's another thing that I noticed. It wasn't really nice what we were seeing when I was in the call. So okay, so I think it's called function call join, call begin screen share. That one will be interesting. Call leave. So this is the one that panics with unimplemented, and it panics here. So we need to update this to the new code. Let's see. Call leave. Grab the active call. We will destroy the active call, which is interesting. We set active call to null. Current equals AC status get. All the status is update swap quit. If all the status is different than intent, having moved past intent means that we have activated the audio stream and the network. Right. So we need to coordinate over this, because you could decide to leave a call before even we started all the stuff. Is it2 pushed up somewhere, anywhere? It's on GitHub, but it's not public. Sorry. I do plan to publish it soon-ish, but I first wanted to get the basics working at least. So the reason why I didn't start this as a public project is, in general, I don't have a problem showing people half-made stuff, and I think that you shouldn't in general. But in this case, it's a very ambitious project, and it's currently like very early days. So I didn't want to publish something that is absolutely horribly undercooked, and so for this time I decided to keep it private for a while more. But then but in any case, what I will do probably is, now that I've mentioned publicly that I've been working on this project, and rather now that Zig has proper async IO and we have a nice path towards completing this, I will publish this, even if it's not complete or like usable at all, just so that people who want to collaborate on it can. So I'll basically try to make this project like open for contributions, maybe more than my projects in the past. Although I feel like I did a decent job with Super HTML and Zine, but I think you can do better. I can do better. So that's what I'll try next. Okay, so this whole system, this whole call live system is managing a nuanced life cycle that I have not been thinking about when upgrading the code to new Zig. More specifically, this status, I don't think I update at all. What is the status? So intent, connecting, connected, disconnected, quit. And yeah. So yeah, Atomic Enum I made myself. Atomic Enum is it's actually a pretty decent thing. Although I don't know if it makes sense in this context here where I'm doing this, but it is pretty nice. An Atomic Enum is basically I use there are certainly use cases for it in this application. I don't know if this one is an appropriate one, but an Atomic Enum is an enum that updates atomically, that has atomic operations for updating, and it wraps a Zig atomic value, but it has a couple things on top of it. One is it has a safety checked lifecycle where it has a starting value. It has progress values that you can move around freely, like you can go from connecting to connected to disconnected. You, in this case, it wouldn't make any sense, but you can also go from connected to connecting if you want. Although, like you can basically, these are like temporary states, and then there's terminal states, in which case here only quit is a terminal state. And once you enter a terminal state, you cannot transition out of a terminal state. There's a panic if you do that. Well, it's undefined. It's unreachable trying to do that. And lastly, Atomic Enums here do one last cool thing, which is that they use core refresh. So every time you flip, you update a Atomic Enum, you trigger a UI repaint. So they're basically a way of updating certain UI elements without locking the entire application state, because because otherwise you would need to, there's one lock for the entire application state, and you would need to lock the entire application state, which you can do. I mean, we do that a lot. You have to, like when painting the UI, you have to have one consistent view of the state. But having these things is good. I think in this case, it might not be particularly important to have this, but in other cases, for example, I don't know, tiny things that need to be updated that the core logic doesn't care much about, you can basically treat them in a more lightweight manner. Are there any good resources for learning the distinction between asynchronous logic, concurrent logic, and parallel logic? And between the distinction, the different implementations? I'm kind of picking it up as I go, but I have no prior experience with writing code that is aware of this stuff. In my case, I've written about this stuff, and I also annoy people about this stuff on Lobsters. So, it's kind of a new thing. It's like it's our take on these topics. So if you read anything not written by us, nobody will make a distinction between these things. So I don't know. My recommendation would be then to take a look at this asynchronous non-concurrency, and I don't know if you have questions. Come post in the Software You Can Love Discord server. I think my Discord server is linked on Twitch as well, somewhere. Otherwise, it's linked on the Zine website. Past that, I don't know. There isn't much research because people usually don't structure these explanations that way, because they don't try to have an ecosystem that doesn't split between async and non-async stuff. So we're kind of the only ones that are trying real hard to make that happen. Although to be fair, we're the only ones trying to make it happen this way. Obviously, there are other languages that can avoid the ecosystem split by either being always everything async, like JavaScript, pretty much, or for example Go. So it's not like it's impossible, but the way we're doing it is kind of unique. Okay, so we wanted to try and understand what to do with the active call stuff. Well, let's retrace our steps from the beginning. Let's go to core. Actually, let's go from the UI. So in the UI, we are in channel list, and in channel list, there's a list of voice channels. And for each voice channel, we paint a join button. If we are not in a call, maybe call. If we are not in a call, or the call that we in is not in this same channel, then we render the join button. And if you press the join button, you call this function. This function says, okay, this should only work if we have a valid TCP connection with the server, which, by the way, we are not checking in the UI. Here I have an unreachable that says UI should have prevented this attempt, but guess what? I don't have UI code that actually checks for this, because I can do it. It's just that you also need to think how you want to visually say this. The idea is you have the application open, but you don't have an established connection with the server. So in that case, you want to show something. I guess you can just show the button grayed out, but it would be probably better to somehow communicate, look, this is grayed out because we're still connecting to this server. So I'll figure it out. In any case, this is one thing that we're doing. And then after that, we create an active call. We write in the active call, this is the host ID, this is the voice channel ID that we want to connect to. Set it in state. Here we're holding the lock to state. Wait, I said we were holding the lock to state. Oh yeah, we are, because this is being called by UI, and UI is holding the lock to state whenever it calls into this stuff. So we make a call join request to the server, and in order to not block the UI, we spawn a concurrent coroutine for which I still have to decide how to handle the future. Although I think I know what to do now. We spawn one of these guys, and this guy is basically waiting to queue. I think we really need to have try put, which we do. You know what? I think we can improve this. So here's how we can improve this. Here's how we can improve this. Here's what we do. We do this. We do con.tcp.queue put, and we're basically doing a try put, which we currently don't have as a function, although we should add it. Could I make a Ziggy post about this? Sure. I can tell you what it is that we were thinking about in our case. I think it had to do with for loops. Something like you basically end up resizing the arena. Let me think about it for a second. So, one problem. It depends on how you do the checkpointing. In our case, we were trying to make it work. We were shaping it precisely as the idea that you can create a sub arena from an arena, and oh, okay. Let's see if YouTube is still alive. Okay, we're okay also on YouTube, it seems. So you're bad. Yeah, so big arena got me. Okay, what I was saying is that we phrased this stuff as in plucking sub arenas from an arena, and and um and it has something to do with for loops, where the idea was that if you so okay, no, there were two problems. One is that if you pluck a sub arena, then you need to make linear usage of it, because if you like create a sub arena and then before destroying it, you create a second sub arena, then you know modifying the first sub arena will force the entire thing to reallocate or something. So it's sorry, it won't work as well as it was before, and it would otherwise. But then there was something to do with for loops, I think, where you could end up with like freeing and reallocating a chunk of memory, but I don't remember all the details. So I don't know. Feel free to talk about it in Zigit, of course. I have the video somewhere. I mean, it's on YouTube. It's one of the live stream recordings on YouTube. I just don't remember which one. Ba-ba-ba-ba-bam. My understanding is that panic and reachable are never supposed to be reached. Yeah. Unexpected unhappy path logic is for errors. Unreachable allows optimizer changes, and panics in release fast are, I don't know, notably panic will not run. Yeah. Wait, did somebody ask about this and I missed it? With the upcoming IO interface, what would be the recommended way of checking if writers' readers are ready? With the upcoming IO interface, you don't. You just let the IO implementation do that for you. Yeah, sorry. I wish I could be more precise. I just do not remember because it's been a while, probably more than a year by now. I just remember that I was thinking, you know what, would be cool to have sub arenas. And by the way, I'll say this also, that checkpointing is not necessarily wrong. And by the way, you also don't need a new implementation to do that if you want, because you can checkpoint your. I think you can checkpoint your arena allocator also with the one in the standard library, because I think we ended up doing that on stream. It's just been too long. Maybe you are certain. Oh, so the reason for this, like the idea is that this is a programmer error. Like you shouldn't be calling this function in any of these states. And the expectation is that these states are handled and prevented by the UI. And so that's the idea. Okay, in any case, what I wanted to do is simulate a try put, which currently we don't have, but we can simulate. There we go. Off topic, where do you start when you want to program a programming language? Yeah, first thing is that you need to be comfortable with parsers. So you need to know how to learn how to write a tokenizer and a parser. Crafting interpreters, I would say crafting interpreters is a great starting point. I do not have personal experience. I do not have direct experience with the Dragon Book, but it's a lot older. And if the fucking Dragon Book talks about Yak in it and other like parser generators, in my opinion, it belongs in you should use it to stoke a fire. I hate. Here's one recommendation also that I have: avoid parser generators. They can be useful for somebody somewhere out there. I don't know, but for learning this stuff, they are a absolute dead end. They won't let you train the muscles that you need to train, and they will give you shitty convenience in return. So avoid parser generators. No Yak. No, I forget the name of the other thing. What does Yak usually go with? Bison and Yak. Yeah, fuck that shit. Um, don't use any of that stuff, or God forbid any of the modern alternatives. So okay, so since we have to manage this life cycle more like seriously, here's what I'm thinking. That we allocate this guy, but we don't assign anything to it yet. I think we should do it this way. So this guy has information about these two things. It has a status. I think it also needs to have space for some futures, like a couple of futures. Optional futures. Hmm. I think we should have. This is where we should keep these futures. Push future goes there. And then, yeah. Okay, I think this is better than it was before, except that option void. Oh, this one is a feature that returns an error potentially. Right. I guess it's fine. Hey, thank you for the resub. Hasan Haya. Haja. I'll go with Hassan. Thank you for the resub, Hassan. So for example, a language like Zig, I guess I'm asking, is it truly from scratch, or do you build up the language from base language like C? No, you do it from scratch. You use an existing language to write the first versions of the compiler, but the language itself is from scratch. And nowadays, the compiler itself is also written in Zig. So, yeah. Okay, so let's see what the problem is. We expect a feature void, but this one is a feature that can error out. So, I think we need to take a look at our. So basically, this is what it is. It can be canceled, and it will return canceled. I think this one also can be that way. Although this one maybe not. This one can be void, but this one is going to be canceled. Okay, so hopefully this won't complain anymore now. Core. Okay, there we go. Okay, so no more complaints. So this is fine. So this puts it in the sends the message in the TCP queue. Okay, so I guess we will be in the intent phase. Then connecting is going to be do I notice a buy for window tiling? I have a window tiling thing in. No, this is mirroring. I have this, which is rectangle, but I don't actually use it. This styling is done by me manually. So, okay, so this is good. The next thing is when we do send that message, it doesn't matter. It's when we receive media connection. So when we receive media connection details, that's when we are connecting in a sense. So here we see the active call. Oh, let's see if we are like transitioning it in here. We see the active call. We see that it is the same channel that we care about. Also, and ac.host ID equals mcd.host ID. These things need to match. Oh my god, there's no host ID in there. Really? There is a host. Oh, it's just not called host ID. Host ID. Also, you know what? Rename. ID. ID. There we go. I hate that I used to not put ID into as a suffix to names that are IDs. That clearly are IDs. Okay, so if the same channel that we're if everything matches, oh there we go. AC status update compare. So we want to go from intent to connecting. And if this succeeded, awesome, because then we proceed. If this failed, ignoring media connection info already connected or quit. So the idea is that we try to connect again. Okay, I'm back. It seems. Doom. Doom. Okay. Can everybody see me? By the way, out of curiosity, is Borg still alive? Test. I can see it. Thank you. Why is any of these errors causing that stuff? That is a problem.